Hey, hi, good evening, everyone. Good evening, friends. Right. So, welcome back to our 30 days free short term training from Python to AI. So, we have successfully completed Python and started EDA module, right? Yes. What did we discuss yesterday, friends? What did we understand? What did we understood yesterday as part of yesterday's session? Okay. Right. So, we'll quickly recap what we have, understood yesterday as part of yesterday's session. Then we'll continue to the next topic. So we started with the second phase of CRISP MLQ. First of all, what is CRISP MLQ? CRISP MLQ is nothing but it's a project management methodology, right? My bad. It's a project management methodology which stands for cross industry standard process for machine learning with quality assurance. So it's a process, in order to work on any machine learning or artificial intelligence project, we are supposed to understand this CRISP MLQ, all the six phases. We have understood phase one, which is nothing but in total there are six phases. The first phase is understanding business and the data. Okay, so we are supposed to understand the business problem that was shared by the client and as well as the data, the characteristics. Right. Then, under CRISP MLQ, the second phase is data preparation. Phase 2 is data preparation. As part of phase 2, we are supposed to again, perform EDA, which is nothing but exploratory data analysis. We are performing a kind of analysis on the data, raw data. Then we'll clean the data, okay, as well as we'll also perform feature engineering. We'll try to understand all the features, okay. So these are the sub phases of data preparation and we are at EDA level, right? Under EDA again we have completed the first moment business decision yesterday. What exactly does EDA hold? It contains, in total, there are four moments: first moment, second moment, third moment, fourth moment, and graphical representation. We are supposed to visualize the raw data. Okay, in total, there are four moments plus graphical representation, nothing but visualization, data visualization using Python. Right. So we have understood first moment business decision. What does first moment business decision measure? What does it measure, my friends? First moment business decision measures the center value or the representative value. It measures the center value or the representative value. It captures the center value of the data. Okay, how can it capture the center value or the representative value of the data? By the concept of mean, nothing but average. Right. So, what is the formula for average? Use chart. What is the formula for average? Mean. Mean is nothing but sum of observations by total number of observations. Right. So mean is calculated using sum of observations by Total number of observations. Good. How do we represent mean as per statistics? Using mu. Using mu, we represent mean, right? So, in all the cases, can we use mean? Can I use mean as, or can I consider the mean value as the center value of, the data in all the cases? No. What is the exceptional case that we have? If my data has, in my data, if I have outliers, in simple terms, outliers are nothing but extreme values. If my data holds extreme values, okay, I'm not supposed to consider mean. Why? Mean is influenced by outliers or extreme values. So in that case, I'm supposed to go and calculate median. Oh, what is the formula for median, or how is median calculated? Good, good. How is median calculated? Median is calculated using, it is nothing but the middlemost value, the center value of observations, partially correct, middle value when arranged in order. Good. It is the middlemost value of an ordered data set. Okay. If my data has in total 5 observations, I am supposed to order them either in ascending or descending. Okay, the middle value will be the median value. Middlemost value of an ordered data set. Akhil, if the data has odd number of observations, yes, we'll get the middle value. That's fine. What if the data contains even number of observations? There are even number of values. Then I cannot get the middle value, right? What I'm supposed to do? What I'm supposed to do if I have even number of observations? Okay, I'll give you an example. There is a data in which there are in total 6 values: x1, x2, x3, x4, x5, and x6. Assume we have ordered all these values in ascending order. Done. Ordered. Now, question is, how can I calculate median for this data? It is nothing but average of middle two values. See, this one gets cancelled, this one and this one. So, do I have a middle value? No, because number of observations are even. So, consider both of them. What are, it's nothing but median will be x3 plus x4 by 2. So, in simple terms, it will be the average of the middle two values, middle two observations. And when you have outliers in the data set, median does not get influenced because of these outliers. So you can blindly go and calculate median and consider median value as the center value, the representative value of our data. Okay, but if you don't have outliers, you can go and consider mean value as the center value. Right. Then comes the third measure with respect to first movement business decision. Okay, so it is nothing but mode. What is mode? Good, good. How do we calculate mode of a data? Most frequently occurring observation or most repeated value. Okay. So what is the use of calculating mode? The use of calculating mode talks about groups, nothing but clusters. And because of mode, you can also get uh, the first moment calculated for non-numeric data. Okay, if you have any non-numeric column, means that is not containing any numbers. For such kind of data also, you can calculate first moment, which is nothing but mode. I can go and get the mode of that specific column. Okay, so if I get one value for my mode, it will be unimodal. If I get two values for my mode, it is bimodal. If I get multiple more than two, it is multimodal mode. Okay, so there are different types of mode, and these mode values, depending on the output for the mode, we can comment on number of clusters, number of groups, how many groups can we derive using our data, or into how many groups we can actually cluster the data. So that can be understood by calculating mode. So what we do is, we generally go and calculate three: mean, median, and mode for each and every column, each and every feature present in the data. So that is the reason, we have understood that majority of the time gets killed with respect to EDA, data preparation phase of CRISP-MLQ. Okay, if our data has a more number of columns, obviously, since EDA is a univariate thing, univariate process, we are supposed to perform EDA on each and every column, one column at a time, one after the other, one after the other, so on. Right? Can mode be calculated for numeric data? Is that possible, friends? Is it possible to calculate mode for numeric data as well, or not? Yes, we can calculate mode for numeric data also. Yesterday, if you observe, if you remember, on which use case did we work on? We worked on iris data set, a very famous data set, in the field of machine learning or data science. Okay, so there is no person without who doesn't know this data set, iris, right? So this iris data set, in total it has 5 columns. One is sepal length, sepal width, petal length, petal width, and fifth one will be the variety of the iris flower. Okay, so if you observe, all the 4 columns are numeric and one column is non-numeric, and we have calculated mode on numeric data only. So what can we infer from this is, mode can be calculated for both numeric as well as non-numeric data. Agree? Yes, obviously. But can you comment the same for mean and median also? No, impossible. How can you calculate mean for non-numeric columns? I'll give you an example. Let me take gender data. Okay, in gender column, I'll have either male or female. And tell me what is the mean of gender column? Can you calculate? No. So it's not only with respect to first moment, throughout EDA. Mark my words, observe whatever I'm speaking. Throughout the entire process of EDA, mode is the only measure that can be calculated for non-numeric data. What does that mean? It means we cannot calculate mean, median, variance, standard deviation, range, skewness, kurtosis for non-numeric data. Why? Because all of these hold formula. There is a formula to calculate these measures. Whereas for mode, there is no formula derived. So that is the reason even we can calculate mode for non-numeric data. Is it clear? Shall I proceed to the next topic? I hope you guys have, performed hands-on with respect to iris dataset. I asked you guys to work on, iris, or not only iris, you take any dataset. Okay, so better keep it, better have the datasets in .csv or .excel format, because it's easy to read the data present in CSV or Excel format. For .csv files, format files, we are supposed to use read underscore CSV function from pandas. For .xlx, xlsx, nothing but Excel files, the function is read underscore Excel from pandas. Okay, so you have to go and do hands-on post session. The same process base. Syntaxes are very simple. What is the syntax for mean? How do we calculate mean? It's very simple. Data frame object dot, what is the column that you are working on? Column name dot mean. Mean is a function, right? So parenthesis. Then execute. You'll get the mean of that particular column. In the same way, if I want to calculate median for the same column, data frame dot column name dot median. Mode, data frame dot column dot mode. And this process has to be continued for each and every column in the data set. I hope it's clear. Now let us proceed to the next business moment. Okay, it is second moment business decision. Okay, first moment business decision was completed, which measures the center value or representative value of the data. It is measuring the center or the representative value. Now we have second moment business decision. What does second moment business decision measure? It measures spread. Okay, it measures spread or it measures dispersion or it measures deviation. Oh my god, what are these? All of these three are same, friends. Spread or dispersion or deviation is nothing but same. So second moment business decision measures spread. It is measuring dispersion. It is measuring deviation. Okay. It is measuring spread, right? From where? Where it is measuring the spread? It is measuring the spread from center value. From center. What do you mean by the center? Nothing but the value that you get from here. The representative value. Right? So, second moment business decision measures the spread from the center, or it measures dispersion from the center or deviation from center. All of these three are same. Okay, Akil, can you just give an example so that I understand well? Yeah. Let me take the same example, my friend. So I'll take my marks that I have scored across 5 subjects out of 5. In the first subject, I got 1 out of 5. Then in the second subject, I secured 2 out of 5. Then 3 out of 5, 4 out of 5, and 5 out of 5 in 5 subjects. These are my marks. Okay, so as part of second moment business decision, we are going to measure variance. What are we going to measure? Variance. Okay, variance has a drawback. Because of the drawback, we go and measure standard deviation. Okay, then we also measure range of the data. So these three are we are going to measure as part of second moment business decision. Okay. Now let us understand what is this variance. Variance is nothing but again the spread from the center. Okay. So the question is, what is the spread from the center? First of all, what is the representative value for my data? If I ask you to calculate the representative value for my marks, what will be the output? What will be the center value? How do we get the center value? Again, I have to measure either mean, median, or mode. But in this case, since I don't have any outliers, so obviously mean will be my, center value. Mean is nothing but 1 plus 2 plus 3 plus 4 plus 5 by 5. So which is nothing but 3. Good. So in this case, I get the center value as 3. Right. So my center value is 3, 3, 3, 3, 3. Why did I write this, or why did I represent mean as a vertical column? You'll understand. What does second moment capture? It captures spread from the center of each and every data point, of each and every observation. Okay, spread from the center. This is my center and this is my actual value. Actual value center, actual value center, right? Now, can I know how many units is one spread from the center value 3? I'll just go with minus. It is nothing but minus 2 units. Okay, the same I'll do for, what? Second subject, 2 minus 3, it will be minus 1. 3 minus 3, 0. 4 minus 3, it will be 1. And 5 minus 3, nothing but 2. So I take each and every subject value, marks, and I'm checking how much spread is these marks spread from the center. How are they spread from the center value? And these are the values. Okay, but what does second moment tell? The spread from the center. It is talking about the spread from the center only. But I want one value, right? That is representing the actual spread of my data. So what I'll do, I'll aggregate. I'll aggregate all of these. So let me keep it as, say x1. So let me take sigma of x1. What will be the output, guys? What will be the output here? If I aggregate all these spread values with respect to each and every subject marks, what will be the output? It will be 0. Why? Minus 2 plus 2 gets cancelled. Minus 1 plus 1 gets cancelled. So 0 plus obviously 0. The output is 0. What does that mean? Does it mean spread in this case is 0? Overall spread is 0? No. No. I have spread, and if I'm trying to calculate overall spread with respect to my data, I'll get 0. What is this? I'm confused. Atil, just clear me from, this confusion. Sure, my friend. See, this is representing the mean, nothing but the center value. If I observe with respect to each and every subject, there is a spread. Yes. But when I'm calculating overall spread, it is getting zero. What does that mean? Does it mean there is no spread with respect to my center value and my original data? No, there is spread. But when I'm trying to get the overall spread, it is getting zero. This is because of uniformly distributed data. If the data is uniformly distributed, obviously you'll get such kind of values and these values get cancelled. Your overall spread becomes zero. That doesn't mean you don't have spread. There is spread in the data, right? So this can be tackled using variance. The formula for variance is given as variance is generally represented with sigma square. Okay, is given as sigma of x minus mu whole square by n. Okay, this is actually representing the same formula of mean, I think. Sigma of x by n. Denominators are same, numerators are also same. In place of x, I am replacing x with x minus mu whole square. That is what second moment tells, right? Spread from the center of each and every value. Take each and every value in the data, you know, calculate the spread between, get the difference and aggregate them. You'll get the overall spread, right? But why are we squaring it? You know, to get this to ignore the zero. Instead of getting zero, if I take square, so what does this become? This becomes 4. This becomes 1. This becomes 0. This becomes 1. And finally, this becomes 4. So the denominator says the numerator is 10 by 5. Number of observations are 5. So this will be 2. What is the variance? It is 2. But is this the original spread from the data? No, this is actually squaring. Okay, in order to not, in order to escape from zero, I'm actually squaring the each and every value in my numerator. But is the 2 that I got for variance, is this the original spread? No, this is squared spread. So standard deviation is given as, standard deviation is represented with sigma, guys. It is nothing but square root of variance. So here you will get the original spread 1.414. Is it clear? Here I'll get, the original spread in the data, the overall original spread of the data, it is 1.414. What is the disadvantage of considering variance value? Variance value will return you the squared spread of the data, but this is not original. In order to get the original spread, you have to go with standard deviation, which is represented with sigma, which is nothing but square root of variance. Variance value is 2, square root of 2 is 1.414. Yes. Any questions? Is it clear? First of all, is it clear? Excuse me. Yep. Now, let us go to the third measure of second moment. What does range help us to calculate? Guys, majority of my students, previous guys, they used to confuse between range function. We discussed range function, right, as part of Python. This range function is different and the range that we will be discussing with respect to second moment business decision is completely different. Both are not same. The range that we have as a measure of second moment business decision will actually measure the range of our data. And you know what is the formula for range? Range is calculated with max value minus min value, maximum value minus minimum value of the data set. Okay, so don't assume the range function that we have understood as part of Python and the range concept that we have with respect to second moment business decision, both are same. No, they are not same, they are different. The range measure is actually giving you the range of your data set on which you will be working, which is calculated using maximum value of your data minus minimum value of your data. This will result as the range. Okay, so as part of second moment, I'm repeating one more time. Second moment business decision measures spread or dispersion or deviation from center. Okay, so as part of second moment business decision, we generally measure variance, standard deviation, and range. Okay, variance is represented using sigma square, and this is the formula. Summation of x minus mu whole square. Mu is representing the center value. See, whatever we have discussed, we are keeping it in a formula. Spread from the center. Okay, so summation of x minus mu whole square by n. But the disadvantage of considering variance value is it written as the squared spread. It is not the original spread. It is not the overall original spread. In order to get the original spread, we have to go and calculate standard deviation. That is nothing but sigma. Okay, represented with sigma, and the formula is square root of variance. This will return as the actual original spread of our data set. And finally, the range is a measure which calculates the range of our data set, and the formula is maximum minus minimum values of our data. I hope it's clear. Now let us, jump into the hands-on part. I'll go and, right. Let us go and work on the same data set. It is iris data set, but let us work on second moment directly, because yesterday we have understood first moment, right? So let us make it fast. I'm importing pandas as PD. What is the use of, or why should we use pandas module? What is the use of pandas module? What is the use of pandas module, friend? Pandas module is used for data manipulation. In order to manipulate the data, we are supposed to use pandas module, pandas library. Okay, so I'm reading a CSV file. Okay, so this is the path in which I have the iris.csv file, and I'm reading the CSV file using read underscore CSV from pandas module. So pd dot read underscore CSV is the function, and I'm executing this line, and the data will be stored in iris underscore data. If you observe the variable explorer, iris underscore data is the variable name. What is the type of iris underscore data? It is a data frame, a two-dimensional object, okay, which has both rows and columns, 150 rows and 5 columns. For better understanding, you can open this data set, and this is the data on which we are going to perform EDA. The same data, guys, 4 numeric columns and 1 non-numeric column. Sepal length, sepal width, petal length, petal width, and finally the variety column, right? So shape function will return us the dimensions, both number of rows and number of columns. Head function will return us by default 5 rows, the top 5 rows, right? Done. And in the same way, tail function will return us by default bottom 5 rows. This is also done. And info function will return us the basic information regarding the data frame, the data set. Okay, so it returns number of columns, number of rows. Then it talks about each and every column name, and for in each and every column, how many missing values we have, null values, and the data types of each and every column, and the memory storage, how much memory is being used for that particular data frame in the memory will be given. And describe function, describe function will return us, you know, in total it returns 8 values. One is count, second is mean, third is standard deviation, fourth one will be maximum, fifth one is minimum, then sixth one is 25th percentile, seventh one is 50th percentile, eighth one is 75th percentile. So, you know, let us get all the values. So these are the values. Just to understand the data in one line, you can go and use describe function. Right. Yesterday we have executed all these lines of code. I'm not executing or I'm not running first moment business decision. I'll be jumping into the second moment business decision, guys. So I'm printing second moment business decision to the console using print function. Just to tell that, from here, second moment business decision has been started. So second moment business decision was printed to the console. Then I'm printing variance. The first measure of second moment business decision is variance. So I'm printing variance to the console. Done. Yes, done. Then let us, dive into the code now. What is the first measure of second moment business decision? It is variance, right? So in order to calculate variance, we had a function in Python. It is var, which will return us the variance measure, variance value. But what is the syntax? The syntax is same. Data frame object dot column dot var. Since var is a function, you are supposed to keep parenthesis. Okay, so when I execute line number 48, it will return me the variance of sepal length column. So let us see what will be the output. 0.68 is the variance of sepal length column. Understood? In the same way, I can calculate variance for sepal width. Yes, you can calculate variance for any numeric column present in the data set, present in the data. But can you calculate variance for non-numeric column? No, it will throw an error. Okay, so in line number 49, I'm going to calculate variance for sepal width column present in iris underscore data. It is 0.189. Now the question is, are these two values the original spread in the data? No, they are not the actual spread present in the data. These are the squared values. How can I get the original values back? Using standard deviation. Okay, I'll perform standard deviation, or I'll try to calculate standard deviation on these columns so that I'll get the original spread of the data. Yes. So I'm just printing standard deviation, a string to the console. So standard deviation got printed. Then again, now let us calculate standard deviation of sepal length. Okay, so the syntax is same, data frame object dot column name dot std, standard deviation. Since it is a function, we are supposed to pass parenthesis. Okay, so can you just think of what might be the output? Variance of sepal length is 0.68, right? So standard deviation of sepal length should be square root of 0.68. Even I am not sure about the value because it is in decimals, right? 0.82. Okay, then let me perform standard deviation on sepal width. Again, the same syntax, data dot column name dot std, which will return me, standard deviation of sepal width 0.43. So this is the actual spread, and this is the squared spread, right? So I hope it's clear. Now let us go and calculate range. Yes, let us go and calculate range of each and every column. I'm printing range to the console using print function. Okay, range function. Okay, in order to calculate range of any data, there is no inbuilt function. So only thing is you have to calculate maximum value. You have to calculate minimum value of that particular column. Then you know get the difference, and this difference will return us the range of that particular data, particular column. That is what we have understood, right? Range is nothing but maximum minus minimum. Okay, so what I'm doing is, we discussed max function and min functions under functions topic. If you remember, max function will return the maximum value, min function will return the minimum value of a data, right? So what is the data that I am referring to? I am referring to sepal length column, so which is present in iris data, a data frame, right? So Akhil, I want to calculate only maximum value. I don't want to calculate range first. Let me see the maximum value, then let me see the minimum value of sepal length, and finally let us calculate the range. Okay, for that you select only this part. Even selection can be done, guys. Select only the maximum of, iris underscore data dot sepal length. This will return as the maximum value present in that column, 7.9. If you don't agree that 7.9 is the maximum value present in sepal length column, open this data set. Okay, the first column is sepal length. Okay, I'll double click on it or just click on once. It is arranged in ascending order. Now I'll double click one more time. It will arrange in descending order. Is it clear now? 7.9 is the maximum value in sepal length column. Under sepal length column, 7.9 is the maximum value. That is what we have achieved. See, 7.9, 7.9. When I calculate or when I execute only for minimum value, if I select and execute minimum value, it should return me 4.3. Let us check, will it return 4.3 or not? For that, I have to select the entire path of, entire portion of this minimum function and execute. Yes, I got 4.3. Now perform the difference. 7.9 minus 4.3. 7 minus 4 is 3. Zero point 0.9 minus 0.3 is 0.6. So together it is 3.6 should be the output. If I execute, the range. Maximum minus minimum. Now I am not selecting, guys. I'm executing this entire length. Okay, I'm executing this entire line. 3.6 is the output. Is it clear? We understood how can we calculate the maximum value of a column and minimum value of a column and the range of a particular column also. So that means this is the range of values present in range sepal length column. In the same way, what I'll do is I'll calculate range for sepal width column. Sepal width. Okay, so max of sepal width minus min of sepal width. The syntaxes are very simple. 2.4 is the output. So this is the range of sepal width column. Akhil, from starting I had a question. You are just working only on sepal length and sepal width columns, right? Yes. What happened to rest of the two columns, petal length, petal width? Friend, that's what I have told you yesterday itself. I'm not working on the rest of the two columns. That doesn't mean you are supposed to work only on two columns. You are supposed to work on all the columns of the data set, all the columns. Okay, as we are running out of time, I'm just doing only on a part of the data. But EDA means it's nothing but exploratory data analysis, right? You are supposed to perform analysis on the entire data, taking one column at a time, one after the other, one after the other. In the same way, it has to be performed for all the columns present in the data. Understood? Right. So don't assume that we are supposed to do only on few columns and ignore the other. Okay, we are supposed to perform EDA on all the columns of our data set. Right. So this marks the end of second moment business decision. Now let us jump into the third moment, that is skewness. Might be you guys may heard, as per our statistics, with respect to our schooling days, you guys may be familiar with mean, then median, mode, variance, standard deviation, and range. All these concepts are not new for us, but skewness and kurtosis are two new measures that we are going to learn as part of EDA. Okay, focus friends. First moment, what does it measure? The center value. Yes. Second moment, what does it measure? Spread from center. Okay, this is also done. Now comes the third moment business decision. What does this third moment business decision calculate, or what does this third moment business decision measure? Third moment business decision measure the direction of spread. Direction of spread. Okay. Akhil, is that similar to second moment? Yes, only a part. Because second moment also talks about spread from center, right? Third moment also talks about direction of spread from center. Okay. So that means additionally it is talking about direction of spread. Is that right? Yes. From your center, if assume this is your data set guys. Okay. So your data set is distributed in this way. Okay. Let me draw it well. See, I'm visualizing my data, okay, and when I try to visualize my data, I found that where is my spread initially? my spread, okay, I see my spread is towards left side of the visualization. And where is my center? you know Here will be my somewhere here, the center. The center will be median. Yes. And this peak is representing mode. What does Why the peak represents mode? Because what is mode? Mode is nothing but most repeated value, right? So obviously a most repeated value should contain a peak. Why? See, because the frequency is more for that particular value, the frequency is more, and assume this is nothing but actually focusing y value, y axis is representing frequency, right? So towards your center, from the center, towards which direction there is a spread. I see there is a long tail towards my left side. Okay, and towards my right side, my majority of the data lies because I see a peak. So this is actually representing the majority data. Okay, in the same way, towards the left side, there is a tail, and the spread is more towards left side, right? So that measure, whatever we are going to measure this spread, the direction of spread from the center is nothing but skewness. Towards which side of your data from the center you have that long tails. Okay, it will talk about the direction of spread from the center, right? So what is the formula for skewness? Skewness is calculated using expected value of x minus mu by sigma raised to the power 3. X minus mu by sigma raised to the power 3. So how can you remember it very simple? In simple terms, since it is third moment business decision, make sure the power will be 3. Right? So this is not summation, guys. This is expected value. I hope you guys are aware of expected value concept. Right? So expected value of x minus mu by sigma. What does mu talk about? Mu talks about mean, the first moment. What does sigma talk about? Standard deviation, the second moment. X minus mu by sigma raised to the power 3. So should I calculate manually? No. Like how we have functions for first moment measures and second moment measures, in the same way we had skew function which helps us to calculate the skewness value of uh, that particular data. Okay, now let us talk about the different types of skewness that data has. Data may contain 3 types of skewness. One is positive skewed, also called as right skewed data. Then negative skewed or left skewed data. If not, zero, which is normal distribution. No skewed data, nothing but normal distribution. If there is no skewness, such kind of data is nothing but normally distributed data. Okay, what is this normally distributed data? Normally distributed data is the data which represents, when you go to a temple, or generally, you may have observed bell, right? So you take a bell and just take only, consider it's only the outer line, right? when you make exactly the bill cut at two parts, exactly at the center, if you make into two parts, you'll get identical parts, right? So such kind of data is nothing but normally distributed. Exactly if I cut the bill exactly at the center, I'll get two identical parts because it is normally distributed. Data is not, there is no kind of spread in the data. Okay, such kind of data is called normally distributed data. Okay, so what is this right skewed data? Right skewed data is the data in which you will find, a long tail towards your right side. You will find a long tail towards your right side. If you identify, if you visualize your data, okay, you will find a long tail towards your right side. What is actually making this wrong tail is, you know, outliers. We discussed extreme values, right? So because of these outliers or extreme values present in the data, you will find a long tail. If you find a long tail towards our right side, such kind of data is nothing but right skewed or positive skewed data. Okay, so from the center, you will find a long tail towards your right side, and majority of the data lies towards your left side. Right? The same thing happens opposite in case of left skewed data. In left skewed data, you will find a the tail towards left side, which is nothing but negative skewed data. Okay, why are we getting this long tail? This is because of outliers present in the data. Because of these outliers, you will find, a long tail towards the left hand side. Right. So, whereas for normally distributed data, the data will be perfectly, uh, it, it resembles a bell shaped curve. Okay, there will not be any kind of tails. Exactly, if you cut at the center, you will have two equal parts, two identical parts. For a normally distributed data or for no skewed data, this is also called as no skewed data. Okay, for a no skewed data, you will have mean, median, and mode. All of these three will be same. Mean equals to median equals to mode. All of these three lies exactly at the center. What about a left skewed data? For a left skewed data, since you have outliers towards your left side, mean will be somewhere towards this left tail. Okay, and this makes a relationship like mean less than median less than mode. So mode will be greater than, median will be greater than mean. Whereas in case of right skewed data, since mean gets influenced by outliers, mean will be somewhere at this position. And median is nothing but middlemost value, so it will be here. Whereas mode, it will be under this peak. So in this case, mean will be greater than, median will be greater than mode. Okay. So make sure to understand these relationship this. So what can I infer from these relationships is by calculating first moment. These are nothing but first moment measures, right? By calculating mean, median, mode of mean measure, median measure, and mode measure present in first moment, you know, I can comment on skewness. Can I comment on skewness? Yes, we can comment on skewness. Simple. You compare all these three values if you get this relationship, for sure you'll get a positive value for your skewness, because this is positive skewed data, right skewed data. And do the same thing, check again for your data, compare the three values, the first movement measures, and if this relationship holds true, then you'll get a negative value for your skewness, which is representing left skewed data. Okay, and in the third case, you know, you'll find all of these three are same. If all these three are same, you'll get no skew data. Obviously, that skewness becomes zero. Zero. Positive, negative, zero. Right? So we'll take a graph on the next day and I'll explain well with respect to these three types of, negative skewed, positive skewed, and no skewed data on the next class. For time being, let us proceed with the code because it is just one line, third moment. Okay, so let me show you the function, then we'll wind up the session for the day. I'm using print function to print third moment business decision. So it got printed. Third moment business decision was printed to the console using print function. Okay, so then I'm printing skewness. Skewness got printed to the console. Now let me calculate skewness for sepal length column. Iris underscore data is nothing but the data frame. Data frame dot column dot function. What is the function used to calculate skewness? Skew function. Okay, so this will return a value 0.3149. So tell me what kind of skewness does sepal length hold? Is it a positive skewed data or negative skewed data or no skewed data? Positive, negative, or no skewed data. What kind of data it is? Sepal length. Sepal length is nothing but a positive skewed data because the value is positive. Right? It is simple. Right? So, since by just looking at the value, I can tell that sepal length hold a positive skewed data. And since it is close to zero, I can also comment that, data is not completely normal. It is slightly positive skewed data, a bit. So when you try to visualize such kind of data, you'll understand. We'll do it, okay? In the next session, we'll do it, friends. Now I'll do the same thing for sepal width. The function is keep. Okay, so let me get the output. It is 3.8 0.3189. Again, it is also same. Again, I see a positive value over here. So positive skewed data. Let me go for one more column. Petal width. Let us check. See. Minus 0.10. So petal width tells that it is holding a negative skewed data. What does negative skewed data represent? That means we had a long tail towards our left hand side. The extreme values are towards the left hand side. So what might be the relation for petal length with respect to first movement measures? Mean will be less than, median will be less than mode. Akhil, is that really true? Yes, friends, you can go and calculate mean, median, mode for petal width. If you go and calculate the first movement measures for petal width, obviously that relation will hold true. Okay, for best example, let me show you what sepal length I have calculated, right? And I see a positive skewed data. It's having a positive skewness, a positive value, right? So let me go and calculate the first movement measures for sepal length 5.48, 5.84. Then what is the median for sepal length? 5.8. See, mean greater than median, then mode 5. Since it is a positive skew data, for positive skew data, obviously mean should be the highest value, 5.84. Then median, let me see, this is the positive rate. So mean greater than, median greater than mode. Okay, that is the relationship, right? See, 5.84 greater than 5.8 greater than 5. Accepted? Will you agree? So those relations again we'll discuss on the next class, right? So this will be the relations with respect to the third moment, business decision. So I'll stop the session here, and if you have any kind of technical questions, yes, if you are free, feel free to ask. And I request all of you to please share your valuable feedback before you leave, as well as hit on the like button if you enjoy our sessions. Yes, friends, it's time for our questions. Yes, first of all, see, in order to do any project, will you jump into the project, my friend, or will you learn the theory part? You'll do some hands-on, then the project, right? What do you say? Would you like to jump into the project directly without knowing anything? Or would you like to learn something and then do the project? So, yes. So that's what we have friends from different domains, right? So let us learn the concept first. Yes, let us learn, then do the project. That is our aim, obviously. So patience is what we expect from you. As these sessions are going very slow and clean, I request all of you to share across multiple channels among yourself. Okay, share across your college groups, your friends, your relatives, whomever it might be. Then ask them to learn, data analytics and data science. We are also going to learn the important algorithms of, AI. Yes, I'm here to teach. Okay, and my approach of doing a project will be the same. Okay, I'll be very slow. If you have any kind of question, don't hesitate of asking me. But only thing is, please join sessions on time, learn, then we'll do project together, right? So that's all for the day. If you have any kind of questions, you're completely free, feel free to ask. And if you don't have any questions, the link has been posted for the form. Please share your valuable feedback, then leave the session. Thank you so much, friends, for joining these sessions and making them awesome. You know, yep. Once again, thank you, everyone. I see no questions. Alright, do hands-on, over the weekend. Then we'll discuss new topics on the next week. Right. Once again, thank you. Have a great day. See you, friends. Bye. Signing off.